Okay, hopefully you can hear me here. There are 13 of you online. I'll wait a little bit more so that you can join. Still 17 people are online. Yeah, please try to share the link. I would thank you that if you can do that, please. Okay, so let us start today's lesson. First of all, let me just correct what I said wrong. So I talked about the word mnemonic. So my pronunciation was correct. My spelling was right. What was wrong? So this is the word that I meant, mnemonic. So it is something that helps you to remember something. Okay, I don't know, any poem or something that will help you to remind something, help your memory to remember that thing. So I spelled it wrong when I was teaching. Anyway, so now let me see, where is the whiteboard cleaner here? So if you remember, we were exploring actually the properties of logarithms, yes? So we learned two things which are actually in the book, and this is the third formula in the book. I want to add a little bit more. Of course, I will not design questions. I need to remember to look to this camera. So I will not design questions in the exam based on those things that I want to mention today, probably if you have time. But it is extremely useful to know about them, okay? So this is the last formula that you need to know, which is in the book. So we had two formulas before. So if you remember, let me write with blue here. So we learned that if I have the log of b times c in a given base, if the base is acceptable, means that a is positive and not equal to 1, and if b and c are both positive, then we learn that if we want to, we can expand this, but the expansion transforms actually the multiplication to addition. So this becomes the log of b in base a plus the log of b, the log of c in base a. And if I ask you, what is the origin? What is the origin of this formula? If you remember in the lecture, you would say this formula as one of the power rules implies this in the language of logarithms. Yes? And then we also learned another formula. The log of the quotient b over c in a base a is equal to the log of the numerator in the same base minus the log of the denominator in that base. And if I ask you what is the origin of this formula, if you go and see the proof, you see that this is the origin of this formula. If you remember, I gave you this formula in its entirety and we rediscovered the formula. But here, if you remember, we had the discussion, I just asked you about this and I didn't give you the right-hand side. So you didn't rediscover it, actually you discover it itself, okay? And then you realize, you try to imitate the proof here to find a nice formula here and you succeeded. And now I am more or less asking you the same question, but I just gave you a hint. So if you want to calculate something like this, there is also another famous formula when you're dealing with powers, which is absent here. And Rocco, if I remember correctly, mentioned that this formula is a to the m to the n is equal to the m times n. So I explored the consequence of this formula in the logarithmic language. I got that. I explored this formula in its logarithmic language. I got that. So I want to also investigate what would be a consequence of this power law for the world of logarithms. Yes? So how should I do that? Do you have any idea? Okay, so let me start. At least you can help me. By the way, please one of you confirm that you can hear me, just through Zoom. Say yes or no. Can you hear me through? Yes. Okay, thank you. Thank you. Yes. Okay, good. Yeah. So, okay, thank you. I'm bombarded with Yana. Thank you very much. Okay, so now let us explore that formula. So what is the starting point? Do you remember when I wanted to calculate these, to obtain these formulas, I gave a logarithm a name. So I would do the same here. So log, I would say let log of b in base a be equals to a number. Let me call it m. By the way, I have already mentioned that what are the properties? A should be positive, A should not be equal to 1, B should be positive, and P is any number that you like. So this is why I write P belongs to R. We don't study complex logarithms. They are very technical, so you will not study them in high school. Okay, but let us go here. And now you can immediately tell me that what is the consequence of this? If I give this log the name m, an immediate consequence of that is a to the m is equal to b. Every one of you knows about this. But now I go back, I want to discover something for b to the power of p, so it motivates me to somehow make b to the p appear in my relation. Okay, there is only b here, but by looking at that, I understand that I need b to power p. So the most natural thing to make b to the power p appears is, I'm asking you, what do you think I should do here? You can answer me through Zoom. Can you tell me what should I do here? Equals b to the power p. You mean this? Your voice was a little bit interrupted. You mean this? Yes. Okay. Now I want others to evaluate this. Do you agree with him or not? Can I go from here to here? Yes, so it means that, so what you say, yes, thank you. What you say is that I have equality, I raise both sides to power p. I am not allowed to just replace. This is not raising to power. What you are doing, you are replacing b with b to the p, which is not allowed unless you do the same thing for both sides, not just one side. Yes, so this means that on the one hand, I want to have b to the p, but I am not allowed to replace b with b to the p unless I do the same thing for the left-hand side. So it means that from here, this is the correct conclusion. Okay, so far so good. But now you see this rule will play the role here for us. So what happens? I have an exponent exponentiated once more, so I have to multiply these two exponents. So this gives me a to the mp is equal to b to the p. Now, this is, I don't know, based on my experience, I think that some students get a little bit confused somehow. Can I write this in a logarithmic form? Can you help me to write this in logarithmic form? So let me write something for you here. So it's crucial to broaden your point of view. Okay, so you need to trust yourself. So if I write this, I am completely, pardon? So let me rewind you again. So if I want to write it in logarithmic form, this is an exponential form. I want to write it in a logarithmic form. I need to put a log here. This was playing the role of the base for my exponent, for my power. This is still also playing the role of the base for my log. But b goes in front, x goes as the answer. Log of b to the power p in base a equals mp. Yeah, thank you very much. Thank you. So thank you very much. So this implies that what you said is the log. So let me tell you what is happening. I am giving the role of b to the p to b. I am giving the role of a to this a. And I am giving the role of this mp to this x. And I want to write this in front. So instead of b, I put b to the p. Yes? Instead of capital A, this little a is playing the role of capital A in this context. And on the right-hand side, what is playing the role of x? mp is playing the role of x. That's it. But now, let me replace this back. M was a name I myself gave to this log. When I am done using my M, it is actually expired. I throw it away and bring it back the real value. This is the log of b in base A. So this is the log of b in base A. Okay? But if I want to write it here, this would be a little bit confusing. Do you agree? If I write this on the left-hand side, this will read this, and people get confused a little bit because of these consecutive letters coming one after the other. So this is why I prefer to write P on the left. Then there is no matter of confusion anymore. Okay, so you discovered the formula. So this is equal to, so if someone asks you what is the log of b to the p in the base A, you would say that I am allowed to put this b, take this b from here and put it back in this log and multiply p here. What is the operation between these two? The operation between m and p is multiplication, so that's also multiplication. So now you discovered another formula. So these three formulas are in your book, and unfortunately they are given in the formula sheet as well. So the log of a to the b to the p, and then I have a here. What happens here? P goes behind, and then you multiply it. Let me put a dot here to emphasize that the operation is multiplication. Log of b a. So these three formulas are the only ones about logarithms that you have in the book. So a should be positive, not equal to 1 in all of them. B and C should be positive because here B and C are involved. But you don't have any limitations at all on P. P can be any real number, of course. If you ask about complex numbers, that's a whole different story. Okay, so this is what we learned today. Okay, now my question is that, can I write this in another language? This is an exponent, this is an exponential relation. I translated it into this language, and that was completely correct and perfect. We got a formula. But you see here, let me change the roles. Let me repeat this relation for you here, but I want to give different roles, okay? So let me clean it here for you. Do it again. I copy paste this part on this part of the board. A to the MP equals to B to the P. And then I write this with blue. Let me write it here. A to the X is equal to B. We know how to translate it into logarithmic language. It becomes the log of B in base A is equal to X. This is something definitely you need to know by heart. Otherwise you don't know anything about logarithm at all. Okay, so now here you told me to give the role of x to this exponent. But I also can give the role of x to this exponent p. There is no obligation there, yes? Because if you ask me what is on the left-hand side, that's a power with mp as its exponent. If you ask me what is on the right, that's also another power with p as its exponent. Here, when I wanted to get this formula, I give the role of the exponent to mp, but why? This is not a have to. Might be you choose to give the role of the exponent to p. Okay? So what I am trying to say, let us interpret these things differently. Here, I want to give the role of this p this time to x. And then I have to give the role of this b to a. Then I will give the role of whole package here to b. And let me rewrite this equation again. So what I get is this. It becomes the log. Instead of b, I put a to the power mp. Okay? And instead of the base a, I put the base b. And instead of the answer, I put p. Okay? I just want you to see that if you also write this, that is also okay, but this is not useful for what I want to do. Okay? But of course, I have to be careful here because the obligation on B was just to be positive. If you want to interpret it in this way, you have to have an extra condition. B cannot be equal to 1. But if someone writes this in this form, if B is not equal to 1, of course, that is also correct. So you see, if I have two exponents, you can interpret it in two different ways. One of them is this one, quite correct, but this is not my goal. It doesn't give me any nice result here. Okay? But here you can immediately find this one. But now I want to go further and get something out of it for you, which is very interesting and might be a little bit surprising. Yes? Okay. So let me know if that is if that's not understandable, let me know now. So you see, let me repeat. What I did, you interpret this in this way, you got your formula in the book, end of the story. By giving the role of the exponent to MP. But on the right-hand side, you also have an exponent. In this problem, you yourself chose to give the role of the exponent to MP, but as you see, that's not an obligation. Let us try to be more adventurous and try to check what happens if I give the role of the exponent to P this time. If you give the role of exponent to P this time, then you will get this rule. Yes? Now, are you ready? Yes? Yes? Do you have questions? Okay. So now let me, so I couldn't hear you anymore. So let me now try to explain. Yes, please. Yeah, I understand there is a bit of delay. Yeah, this shouldn't happen. Am I muted here or not? Might be this is from my side. Let me see. Yes, I am muted. Usually we shouldn't have any echoes. Okay, so let me continue. Might be you understand when I continue. Okay, now what I'm trying to say, so let me continue this one now. So remember that what was M? M was the name that I gave to log of B in base A. So remember, that was my M from the beginning, if you look at your notes. And now let us explore this one. What happens here? So A to the power MP in base B is equal to P. But now here I discovered that if I have an exponent on top of this B, I can move this P to the back of the logarithm. Okay? Here I have MP on top of my logarithm here. So I can move MP to the back of this logarithm. So it becomes MP log of A base B is equal to P. Now, let me divide everything by MP, assuming that M and P are non-zero. When I divide this by MP, MP is gone. What I get is the log of A in the base B. I divide P by MP. But now look, something interesting happens. This P and that P are gone. So this becomes 1 over M. And now what was M? M was this log. So this becomes 1 over log of B in base A. Isn't it interesting? So if you have a log, in front of the log you have A, the base is B, you can write 1 over, you write log again, but you interchange these two. So it becomes B in the base A. But of course, for this formula to be correct, A should be positive, B should be positive. But because A appears as the base, A shouldn't be equal to 1. Because B also appears as the base at some point, it shouldn't be equal to 1. So you get a very, very nice formula. I don't know for some reason why they didn't mention this formula in the book. So that's an extremely important formula. So for example, the log of 2 in base 3 is equal to the log, is equal to 1 over the log 3 in base 2. It's a very nice formula. And let me multiply this. This means that the log of 2 in base 3, if you ask me what the number is, I don't know. But I know that if I multiply it by the log of 3 in base 2, can you tell me what would be the answer? Even though I don't know the value for this exactly, I don't know the value of this exactly, but I know if I multiply these two, I know the answer exactly. Can you tell me what the answer is?
1.
It's 1. Thank you. Because these two numbers are reciprocal of each other. One of them is the reciprocal, the inverse of the other one. So it's a very, very nice and handy formula when dealing with logarithms. Is that clear? So I want you to, if you are interested in mathematics, I want you to add this somewhere in your notes. It's good at least to know about this. There is another formula. So you see, it was nice. First, I used the normal way of thinking. I got this formula. Then I changed my perspective. I gave the role of the exponent to p this time. I got this formula. But when I got this formula, I used the same trick here. I took this MP to the back of the logarithm, and then when I divide, something interesting and new happens. Now we understand what is the relation between the log of A in the base B and the log of B in the base A. They are reciprocal of each other. So it's very nice. It probably, when I was learning this, I couldn't guess this in the beginning, that there is a very nice relation between the log of A in the base B and the log of B in the base A. So for me, it was surprising when I was at your age. Okay, and then let me tell you something else. This is something that you need to know very well. These three formulas are extremely important. Multiplication to addition, division to subtraction, power to multiplication. Instead of having the power, I go back. Okay, now let us try to see how this will go. This example is very important. I want you to understand that, but I really want you to be able to do it very fast. Of course, the fast part is not included in the exam. That is for your own benefit. So here, let me ask you this question. For example, I have the log of b to the 2 times c to the 3 divided by d to the 4, for example, e to the 5, and let me call the base a. I want to expand this one single log as much as possible. So I want to write this in the full expanded form. You might say why this is good. Forget about that. Might be there are some applications for that coming later. But assume that you want to expand this one single log to as many logs as possible. Okay, don't get confused. The first formula that comes handy is the second formula. Why? Because if I ask you what is this in front, you would say that is the quotient of this expression and that expression. So when you say that is the quotient, it means that you need to use this quotient rule first. Okay, so let me change my color. What I write in the blue is actually the answer. So this becomes the log of the numerator in the base A minus the log of the denominator in the same base A. So I am using this fact that the log of a fraction is the log of the numerator minus the log of the denominator. But the numerator was b squared c cubed. The denominator was d to the 4 e to the 5. But now if I ask you what is this one, if you want to read it in English, you would say this is the product of b squared c cubed. So that's a product. So the product rule has to be used. The same story here. If I ask you what is this, you would say this is the product of d to the 4 e to the 5. So again, the product rule should be used here. So if I use the product rule here, this becomes the log of b squared in the base a plus the log of c cubed in the base a. But this minus sign, I have seen students make this mistake. This minus sign is for the whole expression, but the whole expression is a product rule. So I have to open a pair of brackets and write the answer of this guy here. So it becomes the log of the first one in the base a plus the log of the second one in the base a. So you see the first thing that I did, I used the quotient rule and then the product rule. I hope that you immediately can guess. The next level is to use this power rule because each one of them has an exponent. So these two can go to the back of the log. You can write 2 times log of b in the base a. You take 3 down, so it becomes positive 3 log of c in the base a. Here, I take 4 here. So let me just be patient and write it in 2 steps. 4 down, and then 5 down. And then, of course, I am now on the safe side. I can multiply this negative sign inside. So this becomes 2 log of the b in the base a plus 3 times the log of c in the base a. But this negative sign is both for this one and for the next one. So this becomes minus 4 log of d in the base a, and then minus 5 log e in the base a. So this is what I ask you to do that. So you see, I am using all these 3 formulas. So I use the quotient rule once, I use the product rule twice, and I use the power rule 4 times. Then I will have the full expansion of this one log. So you see, this is this one. And what I want you to do, it is possible, I want you to be able to go from here directly to the last line. Okay? Of course, I told you that the speed is not irrelevant in the exam, but we are talking about math in general. If you're able to do these things quickly, you'll learn them better. So hopefully you can see the pattern. Can you go directly from here to here? I would say that, okay, if I have any product, for the numerators, I put positive signs. For the denominators, I put negative signs. And then these exponents will go to the back of the logs, corresponding logs, and I will have this expansion immediately. For example, if I want to give you another example, so for example, let me write this. The log of b to the 2, c to the 3, and let me write d to the power of minus 5, and then I write a. I want to expand this logarithm as much as possible. So how should I do that? Immediately. I hope that you can accompany me with this. Yes, I would say 2, and I would write the log of b in base a. Then I would write plus, 3 goes down, and I will have the log of c in base a. But now I am going to the denominator, so I have to put a negative sign because I am going to the denominator. But the denominator exponent itself is a negative. So in principle, it becomes negative 5, and the log of d in base a. But negative 5 is nothing except positive 5. So I would write positive 5. So you see, I was able to expand this log immediately. So, but I don't want you to do it blindly, just memorizing. If someone asks you how you could come to this answer, you would say that I used the quotient rule once, the product rule once, the power rule 3 times. But you see that the combination of these formulas will enable you to write this immediately. So that is what I want you to learn. Okay, so I would also add this to my list. So the log of a in base b is equal to 1 over log of b in base a. Here a should be positive, not equal to 1. B should be positive, not equal to 1. Okay, now I want to give you a nice problem. We want to add one more formula here. We can add 2 more, and when we are done. So, if I want to ask you this formula, so we learned that if I have an exponent on top of b, p goes to the back of the log. Now I want to ask you the question, what do you think will happen if this p is not on b, is on the base itself? Okay? What happens then? Okay, but it might be that is a better idea if before going that. Pardon? Let me before going to.
It's the same idea. It's 1 over b. Like instead, it's 1 over b log b base a.
Yes. What is the answer then? I think I heard you. That was correct. So let me try to give you a little bit examples before going to the next level. So for example, if I ask you to calculate log of 100, one way to do this is what you learned before. But now, if you want, it's better to use the formulas as much as possible. So if you give me this, one way of dealing with that is to write 100 as 10 to the power of 2. And now I know the rule. If I have a power there, this will go to the back of the log, so it becomes 2 times log of 10. But log of 10 is also another theorem. The base is 10, so I have a log of a number in its own base. So we learned that that number is nothing except 1, so 2 times 1 is actually 2. So you see, this is a second method to solve the problem using the formulas. Okay? So that is important. So for example, if I ask you what is the log of 64 in base 2, hopefully you know that. What is 64? 64 is 2 to the 6 in the base 2. And then this 6 goes behind the log, and then it becomes the log of 2 in the base 2. But the log of any number in its own base is just 1. So this becomes 6 times 1, it becomes 6. Of course, you were able to calculate this with the other methods. You can just do it mentally. But I want you to see that if you use the formulas, that's also possible. And I want you to learn how to use the formulas. Okay, now the question is this. If I go to the next question is that if I have b here, but instead of the normal base, I have my base to some power p. I want to see what can I write in front. We already saw that if p is there, it goes back to the back of the log. Now I'm asking you what happens if p is here. you see that you can write something similar. If I heard Hussein correctly, I think he did the correct. He gave me the correct answer. But let me just repeat it. If I want to solve this problem, how should I do that? Do you have any idea how to prove it? How to come up with a formula for this? This becomes crucial here.
So we can start off by using that formula. So we interchange a to the power of b and b, and then we put so it would be 1 over, what you're writing.
Yes, thank you. And then this rule is now familiar for us, because now you see the power is not on the base. Thank you very much. That is the goal. Thank you, Rocco. So here you see that p is no longer on the base. P is on the number in front of the log. But I know how this will act if p is on this piece. Okay, I have to move this to the back of the log. So here I would write 1. I will move p here. It becomes p log of a over b. But hopefully you agree with me that I can write it as 1 over p multiplied by 1 over log of a in the base b. So this becomes 1 over p log of a in base b. 1 over that, I can bring it up again to have the same base and the same number. So b goes there and a goes here. So it is also the second nice formula which is missing in the book. So you see, if p is on top of this one, it goes straight back to the back. But if p is on the base, it does not go straight to the back. Its reciprocal, its inverse, will go to the back. So if p is going to the back from here, you need to write 1 over p and put it at the back of the log. Okay, so let me add this formula also to this list. The ones in blue are the ones in the book. Pardon? The last step.
How did you get from 1 over p to, how do you get from 1 over p times 1 over log?
Yes. This one is equal to this one. Yes?
Because of the fourth formula.
Because of this fourth formula, yes. So if I inverse, these two will interchange. So now I can add this formula also here. These are nice formulas. So a, b here, a to the p here. This p becomes 1 over p and goes back. And then I will have log of b a. Of course, again, p is a number, of course, which is not 0, because 1 over... So here, p is not 0. A is positive and not equal to 1. B is positive. Okay? So, for example, let me give you this example. So log of 8 in base 4. If you go to one of my previous videos, you see that we solved this together. By what method? By the method that I called it x, and I determined x, if you go back. But we don't need to do that anymore if we can use the formulas. That's, of course, completely okay with me if you solve it in that way, but I want you to learn this more interesting way as well. So you see here, I will write it as log. Every one of you knows that 8 is nothing except 2 to the 3. 4 is also 2 to the power of 2. Now, I am combining these two rules. I have an exponent here. This exponent will directly go to the back. But I also have an exponent here. This does not go directly to the back. Its reciprocal goes to the back. The reciprocal of 2 is 1 over 2. So 1 over 2 goes to the back. There is already a 3 there, so I have to multiply 3 by 1 over 2. And what is left for me is 2 from here and 2 from here. But now 3 times 1 over 2 is 3 over 2. And if someone asks you what is this is the log of 2 in its own base. It is 1. So the answer is 3 over 2. So if you don't mind, let me just remind you, if you have forgotten in case, let me tell you that you don't need these formulas to answer this. But this, I would say, it's a much more advanced way to do that. Here, if you remember, if we cannot guess, we called it x, and then we say that 4 to the x is 8. Instead of 4 to the 4, I wrote 2 to the 2 to the x. Instead of 8, I write 2 to the 3. And then this becomes 2 to the 2x equals to 2 to the 3. Then I concluded that 2x is 3. Then I want to make x alone, so I divide by t. So you see, this answer is exactly the answer that I got. So I am not telling you this exercise can be in the book or can be given to you in the exam. But now you have two opportunities. Either you use this crude method, which of course is very nice because your understanding about logarithm brings you this solution. But this is also interesting to know if you can somehow memorize these formulas so that you can use them. Okay? I don't think they are hard to memorize, but that's up to you. I just want you to see this rule. Okay. Another important rule which is missing in the book, and if you remember, I want to tell you that how you can calculate the log in other bases in your calculator is called the change of basis formula. Sorry, the change of base formula. Okay, so we want to talk about that one a little bit as well. Okay.
So Babak,
yes?
My calculator actually has the option to choose the base, so do I need to know this?
What do you mean?
I can choose the base. I don't have to do it only base 10 on my calculator.
Okay, so you have that option available. I didn't know that. Do you have a specific button on your calculator?
Yeah.
Okay, nice. Okay.
Yeah, it's a button. It's a log, and then I can choose it.
Okay, so nice. I didn't know about that because probably I'm an old man now. But anyway, it doesn't mean that you don't need to learn the change of basis. Of course, I will never ever give you a question that you have to solve it using these formulas which are not in the book and not in the formula sheet. But I really recommend you to at least see them once. Okay, now let me go to teach you another formula. So that is the change of the base formula. It's very interesting, you know. If you want, for example, let me just give you some numerical example. If you have the log of 2 in base 3, the interesting thing is that you can go to any base that you like. For example, let us choose base 5. Then I write a fraction. I take 2 to base 5. I take 3 to base 5. And then divide them. These two are equal. So you see, the original logarithm was in the base 3. I changed the base 3 to base 5, but the price that I have to pay is to write a fraction whose numerator is the log of 2 in the base 5, and its denominator is the log of 3 into the base 5. There is nothing specific about 5. I can go to any other base. Of course, the base should be positive and not equal to 1. For example, let us choose 7 this time. What can I do? I can write the log of 2 in the base 3 is equal to the log of 2 in the base 7 divided by the log of 3 in the base 7. That's also okay. But probably there is a better choice. What if I am allowed to choose whatever base I like, why should I choose 5 and 7? Let us choose 10. Let me choose 10. Okay, in that case, log of 2 in the base 3 becomes the log of 2 in the base 10, and then log of 3 in the base 10. But I told you, when the base is 10, we don't even bother to write it down. So it takes a very nice simple form. It becomes the log of 2 divided by log of 3. As simple as that. So for example, if your calculator doesn't have this button that Rocco described, you can use this relation. If you want to calculate the log of 2 in the base 3, you can calculate the log of the number in front and then divide it by the log of the base. What you get, this can be done with your calculator. There is a log button on your calculator, definitely, and there is a division button on your calculator, definitely. So you will be able to use this formula and write it very, very nice. Okay? So, but of course, if you are interested in mathematics, this shouldn't be so fun for you. It brings you excitement, but the real fun would be to see why this is true. Why the log of 2 in the base 3 is equal to the log of 2 divided by log of 3. Because if you remember, when we wanted to define the log, there were no role that we gave to division. The definition of the log of 2 in base 3 is x if and only if 3 to the x is equal to 2. And you don't see any apparent relation for this log and division. You see the relation between the log and exponentiation, but you don't see the direct connection between the log and division. But now I am telling you that if you want to calculate the log of 2 in the base 3, calculate the log of 2 divided by log of 3. Division comes into the game. So we want to understand that part. Okay, so let me try to motivate you very, very simply. This is, by the way, given in the book, but they hesitate to give you the formula. Okay, let us consider this scenario. So the log of 2.
What do you mean that they hesitate?
I don't know. They have mentioned this method that I am going to describe, but they haven't written this formula in the list of formulas. So this is why I'm saying it hesitates. From my point of view, this is also very important formula. If I want to teach log, if I want to write my own notes, I definitely will include these black formulas into these blue formulas. That's what I'm saying they hesitate. So let us understand this connection. So let me call this one x. So then you conclude that 3 to the x is equal to 2. Okay, now can you help me a little bit? Here I have 3. Can you tell me how can I write 3 as an exponent with base 10? This you should be very quick at it. I want to write this in the form of an exponent whose base is 10. So what should I write in front? What should I write? It is 10 to the log of 3. Do you agree with me? Everyone should be very comfortable with this.
Yes.
10 to the log of 3
Yes.
is 3. Because the base here and the base there are the same, everything will be canceled out and I will get 3. I will do the same thing with 2. 2 can also be written as 10 to the power of log of 2. This is in the book and we have studied that. Now, this is also in the book. This is the definition of the log. Instead of this 3, I choose to put this complicated form. You will see what's the benefit. Instead of 3, I write 10 to the log of 3, and then I have another exponent. Instead of 2, I do the same. It becomes 10 to the log of 2. But I have another rule. I have one exponent. I am exponentiated once more. So the rule is to multiply the exponents. So this becomes 10 x times log of 3 is equal to 10 to the power of log of 2. Now I have equality. I have a power of 10 on the left. I have another power of 10 on the right. This equality cannot hold unless the exponents are the same. So this means that x times log of 3 is equal to a log of 2. But my goal is to make x alone. I want to find x. So I divide both sides by log of 3. Yes? So then this becomes alone. It becomes x. On the right-hand side, I have already a log of 2. I divide by log of 3. It becomes this. I cannot go further. So this is my x. On the one hand, x is equal to this. Everything that I did here was completely legitimate and reasonable. On the other hand, x is equal to this guy. I myself called it x, and I explored the consequences of this designation, and I got this x equals to that. So this x in the beginning is the same x that I got here. So these two have to be equal. So then we got our formula. Be happy. So log of 2 in base 3 is equal to log of 2 divided by log of 3. As simple as that. Might be the reason that the book has hesitated to write this down, because they want you to learn the procedure by doing it every time. After that, after a while that you are confident that you know it, I myself prefer to do it using my memory. That's up to you again. But this is completely understandable. And then I hope that you understand there is nothing specific about base 10. For example, let us follow the same argument, but instead of focusing on base 10, let me, for example, this time focus on base 5. Let me just redo the calculation. So this is missing in the book. They have only talked about base 10, but it doesn't matter if I choose another base. So what I do, I will write it like this. I will start from this again. Log of 2 in base 3 is x. This implies that 3 to the x is 2. Now I am choosing to use base 5 instead of base 10. Okay, but that's not a big deal, because 3 can be written as 5 to the log of 3 in base 5. You see, this one and that one are the same. Everything is gone, so 3. That's completely okay. I can do the same with 2. I can write 5 to the log of 3 in the base 5. And then I put them back into that equation. Instead of 3, I put this fancy combination. So 5 to the log of 3 in the base 5 to the power of x. Instead of 2, I write this combination. But the same rule applies. X is multiplied by this is equal to this. And now I have a power of 5 on the left, another power of 5 on the right. They are supposed to be equal. This cannot happen unless I have this. I made a small mistake somewhere. Yes, you didn't point it out. This is 2, sorry. I don't know why I wrote 3 here. Nobody complained. So 2, it's 2. I have to write 2 here, sorry. So this is 2. And this is also 2. Yes. And now I want to make x alone, so I divide everything by this guy. So this becomes the log of 2 in base 5 divided by log of 3 in the base 5. This is on the one hand. On the other hand, x is this guy. So these two should be the same because they are both the values of the same x. So this means that the log of 2 in base 3 is equal to the log of 2 in base 5 divided by the log of 3 in base 5. So you see, I get the similar formula. So it is completely clear what number I choose as the base is irrelevant. I can follow the same type of calculations and I get this one. So we can write a nice formula. This formula that I'm writing is called the change of base formula for logarithms. So it is the log of a, so let me write it as usual notation. B in the base a is equal to the log of the base of b in any particular base that you like. Let us call it c, any number that you like, divided by the log of a in the base c. Of course, for this formula to work, a should be positive, a should not be equal to 1 because a appears somewhere in the base. B should be positive, c should be positive, c should not be equal to 1. So under these conditions, you can write this. And that is the change of base formula for logarithms. So, but I think the goal of the book is to learn this method by overdoing it every time. Yeah, try to do it as much as you like until you really know how to do it, and then of course you can use it in your head. Okay, let me also explore a nice thing here. You see, I told you that you are allowed to go to any base that you like. Let me choose to go to base A. Let me choose to go to base A. So then what happens? It becomes the log. Sorry, it doesn't make you anything. Let me go to base B. Let me choose to go to base B. So then it becomes the log of B in the base B, the log of A in the base B. But the log of base B in the base B is 1. And you see, you get the same formula back with a different method. Log of B in the base A is equal to 1 of log of A in the base B. We had found this formula in a totally different way. Now we also use the change of base formula to find the same formula in a different way. So you see, it's very interesting and exciting if you explore these things on your own. There might be some formulas out there, but I don't want to disturb you with that. Probably the hardest one, I just write it for you, but you don't need to know it. A to the power of log of B in base C. There is a very strange relation. If you have this combination, none of them are equal, by the way. There is a very nice relation. It is not trivial at all, that you can interchange this number with this number without affecting the result. So you can write B to the log of A in the base C. But the proof is a little bit harder. So you see, if I have these things, I am allowed to interchange these two numbers that are far away from each other, but the answer to this is exactly the answer to that. The answers are the same. But yeah, so these are the only formulas that even myself know about the logs, okay? But the ones that I wrote in blue are the only ones that you have it in the formula sheet. Yes?
A had an exponent or B had an exponent. Would that affect the formula?
No, I mean that what you have here, you can interchange it with this one. If you have an exponent here, you need to bring it with its exponent down. If you have an exponent here, b to the power of p, b to the power of p will go here and a will go there. In that case, this formula is still valid. Okay, so on Friday and on Monday, I think I want to complete what is left over. So I want to give you some examples, some exercises. I will write on a school cell which parts to do today or up to next time. But on Friday and Monday, we will complete everything, and this chapter will be finished. And then we go to the next chapter, but every now and then you get an exercising session to practice for the coming test. Okay? I think on Monday, we will decide which date to put it that fits every one of you mostly. Okay, so if you don't have any questions, I want to thank you first for being with me here. I want to end this stream, and then I will be on Zoom for a while if you have any questions. Thank you very much.